So now we will talk about the framework of the hypothesis testing. So why do we need the hypothesis testing? First of all, so as I told you in the estimation procedure, what we do usually, we just find out the estimate of the parameter theta, population parameter theta, with respect to the sample size. All right, but that sample estimate will not be the same as the population parameter. All right, for example, in the class, suppose I have total 100 students, the population size is 100, and in that one I am going to claim that the mu, the average marks of the student, okay, average marks of a student is 75%. Suppose I am going to take a sample of 20 students and I find out the average mean of the student. Is it necessary that whatever the estimates I will get, it should be 75%? Is it possible? Most of them it is not. Okay, most likely it is not possible that I will get the exact 75%. It will be surrounding 75%. It might be 65, 68, or 70, or 80, or 76, 78, like that. It may be surrounding the 75%, but it should not be exact 75% because we are taking the sample of 20. We are not going to consider all the 100 students. So that means we are going to lose the information here. All right. So when you are going to lose the information, definitely your parameters, estimated value of the parameter is going to be affected by that one. All right. And for that one, if it is going to be differ from 75%, suppose 68 or 70 or 80 or 76, like that. So can you tolerate that difference from the population parameter or average marks of 75% or not? That is basically your, for that one you need the testing of hypothesis, right? So for other example, suppose you are going to make some vegetable or some curry, and in the curry the 2 spoon of the salt was needed, but you put suppose 2.5 or 1.5. All right. So how much you can tolerate? If 2 spoon of the salt is needed, so when you are going to put the salt by the spoon, so exactly two you are not going to put. Somehow more or less may happen. Depends on person to person, right? So if it's less or more, so how much less or more you can tolerate? That is the important thing. So if you are going to because you definitely you cannot go for the 4 or 5 spoon of the salt, or you cannot go for the 1 teaspoon of the salt while you needed the two, right? So that's how we need the testing of hypothesis. In that one we always just make two hypotheses. One is null hypothesis. In that one the status, we assume that status is equals to, and our aim is to disprove that, and we want to reject it basically. And alternative hypothesis that we denoted by H1 or HLA, that is we want to basically establish. All right. So here one important thing is that when you are going to talk about the testing of hypothesis, how you will find out the alternative hypothesis. All right, there are three possible ways to design the alternative hypothesis. If I'm going to consider this one, my mu is 100. So in that case, my null hypothesis will be mu equals to 75%. Right. But what will be my H1? My H1 will be basically three possible ways are there. For that one, first is not equals to. Second one is mu is greater than 75%. Sorry, not 70, 75%. And third one is mu is less than 75%. So there is a one common thing that mostly people do the mistake here. First of all, most of the times when you just attend any lecture of the testing of a hypothesis, they says that you can choose the alternative hypothesis by your own, but it is not like that. It depends on your study. Okay, in study means where underestimation is more serious or overestimation is more serious, or both are equally serious. Okay, underestimation and overestimation both are equally serious. So at that time, we just choose the alternative hypothesis according to the situation. For suppose that I have a bike and I assume that the average of my bike is suppose 70 km per liter. All right. So if I'm assuming that my bike's average is 70 km per liter and I actually it is giving 65%. So what I am doing here, I am assuming overestimate. I'm doing overestimation here. So in this condition, overestimation is more serious. If I'm assuming 65, 60 and it is going to the 65. So I was doing the underestimation. Underestimation is not serious at all for me. All right. For me, overestimation is more serious in this condition. All right. And the second case is that if I'm going to take any doctor is giving a treatment to any patient, and in that situation, the doctor is assuming that the disease is very crucial, even though it was not crucial. Okay, so in that one, what doctor is doing? Doctor is overestimating the disease. Okay, it is going to overestimate. So it will not affect the patient at all. But if in this condition, doctor is assume that disease is not crucial, but disease is crucial, so at that time, what will happen? They will definitely, it might possible that patient will lose the life, right? So in that condition, underestimation is more serious in compared to the overestimation. All right, now here the condition that when both of them are equally serious, you can give the example. Suppose newspaper boy problem, how many newspaper he should buy every day to sell. So in that one, suppose he buys some newspapers where if he buy the less number of research, less number of newspapers, so at that time what will happen? He will lose the customers. So it is not the direct loss, but it is the opportunity loss, right? And if he buy the more research paper, sorry, more newspaper to sell, so at that time what will happen? The newspaper will remain with him and he has the direct loss. So in that condition, in both condition he has the loss there. So he has to be very optimistic that he should not have the loss on the both side, not the opportunity loss as well as he should not have the direct loss. So here he should give the equal weightage to the both of side, right? So at that time we will take the alternative hypothesis that mu is not equal to 75%. That is basically two-tail test. Okay, here it is basically called as the two-tail test, and both of them is called as the one-tailed. Right. This is called as the right tail. This is called as the left tail test. All right. So by the definition of the hypothesis testing, so here we are saying that we can reject H naught, but we can only fail to reject H naught, not accept it. So basically, what is the definition given by the R.A. Fisher is that a test of the hypothesis is the procedure for decide whether to accept or reject the hypothesis based on the random variables. So in that one, we just basically try to reject the null hypothesis. So according to the Professor R.A. Fisher, a hypothesis which is tested for the possible rejection under the assumption that it is true is known as the null hypothesis. All right. So during the testing, we have the two type of errors, that is type 1 error and second is type 2 error. Okay, type 1 error is called as the false positive and type 2 error is called as the false negative. All right. What is basically when you reject the null hypothesis when it is true, that is called as the false positive or type 1 error, and second is that you accept the null hypothesis or you fail to reject the null hypothesis when null hypothesis was false, that is called as the your type 2 error. For the real life example, suppose if I want to purchase some electric item and electric item is good but I reject it. Okay, so that will be my type 1 error. And second is that if the product was not good, okay, and I accept it, that is called as the type 2 error. All right. So here the p-value approach that we use to find out that whether we should accept the null hypothesis or not, or we should reject the null hypothesis or not. So the probability of observing the test statistic as extreme or more extreme than the observed value, assuming that H naught is true. So P is basically the probability that test statistic is greater than equals to the test observed value under the H naught, that is called as your P value. All right. Here P is basically, if P is less than equals to alpha, we reject the null hypothesis or we say that statistically significant, or if P is greater than alpha, right? So we say that we fail to reject the H naught. All right. So here most of the time people ask that which error is more serious. All right. Type 1 or type 2. So here type 1 is more serious in compared to type 2. Why? Because if you just say how you define your critical and acceptance region, right? So you define the critical region, basically omega is Z belongs to the Rn, all right, given that H naught is rejected if Z belongs to the omega. All right. So whatever the null hypothesis rejection region you are assuming under the H naught. All right. So that's why your type 1 errors becomes more serious in compared to type 2 error. All right. So there are so many tests that we apply, that is basically called as the Z test for non-sigma when population variance is known and for large sample size, and T test we apply for the unknown sigma when capital population is not population variance is unknown. So at that time we apply the T test. The formula of Z test is x bar minus mu naught divided by the sigma upon under the root n, and T test the formula is x bar minus mu naught divided by the capital S divided by under the root n. Here capital S is basically your sample variance, and these two tests are for the mean testing, and then for the testing of the variance we have the chi-square test and the F test. Chi-square test is for the testing for the variances, and F test is basically for the comparing the variances between two population. All right. So assumption here, what is the assumption that matters a lot? The most classical test assume the normality and independence and the homozygosity in the population. All right. So after that, we just go for the confidence interval. The confidence interval is basically the probability that theta lies between the limit L and U is equals to 1 minus alpha. That is basically your confidence interval, and alpha is basically is your level of significance. All right. So what is the basically common misinterpretation about the confidence interval is that there is a 95% probability that mu is in this interval. No, that is the wrong. The correct thing is that 95% of such interval would remain the mu. All right. Basically, mu will be there. What is the mu? 100. If you have the sample size of you are going to generate, uh, for example, if you are generating the 100 random numbers, say x, x1, x2, xn, x100 from the normal distribution. All right, from 0, 1 in R. So the command is R norm 100 0, 1. So when you will find out the confidence interval for the observations, then definitely you will get the at the 95% interval you will get some confidence interval, right? By this formula. So in that one, few observations will, whatever the 100 observations you generated, few observations will be out of this interval. Okay. So what when you are going to do that one, it means that whatever the value you are going to remove from the confidence interval, that will not lie in that 95% confidence interval, that was not from the normal distribution. No, that is wrong. That 5% observation that you are going to remove from this 95% confidence interval, they were also from the population, but you are saying that you are going to remove those observations. Okay, you assume that they are not going coming from that one. All right, so that means that 95% of the such interval would contain the mu. That is the right interpretation. All right. So here